Vishwa, good evening, Vishwa. Everyone, good evening. New topic starting, magnetism. Ready for it? So in science, we are going to start magnetism right now. This will, because you will be having extra classes. Yes, good evening, everyone. This full week you will be having extra classes and I will be there with you. Now listen everyone, magnetism chapter we are starting with a note that whenever you are means you are in an electric field, magnetic field will be generated. Okay. I hope you might have understood this one. Okay. Now look here. Understand this one. I'm going to start the class. Everybody, please join the session. I have messaged everyone to join the session. See, look at in magnetism chapter, what and all things you have to study and what and all work you have to do. So this is some of the most important thing. Like first, we need to understand what is magnetic effect, what is magnet, what is magnetism, and how magnetic lines of forces are there. Are they interacting each other? What is magnetic lines? Everything has to be understood nicely. Now, one by one, I'll explain every factors. One by one, I'll explain every factor. Just give me 1 minute. One last link I have to send. So now look here. So when somebody will be asking you about magnetism, just go for it. So it was found that magnetism and electricity are related to each other. This means that electricity can be used. Yes. So we need to understand that if somebody will be asking you about the effect of magnetism, how it is exactly going to be, we are going to understand this. Like when current will be passing through a conductor or a conducting wire, it will be generating magnetic effect. How it will be generating magnetic effect, where it will be generating magnetic effect, what will be the impact of magnetic effect of any conducting things or any other things, so that we need to understand in this chapter. Okay, so now we are going to first go one by one things. One by one, this means that electricity can be used for generation of electromagnetic effect, and this effect is called as electromagnetism. So 100% electricity can be used to generate electromagnetic effect. Okay, now changing magnetic field line can also produce electricity, and this is called as electromagnetic induction. See, electromagnetism and electromagnetic induction, these are two different things. Electromagnetism and electromagnetic effect, I repeat, electromagnetism and electromagnetic effect, these are two different things. Understood? So, what is the meaning of electromagnetism? If a conducting wire, current carrying conducting wire will be there, that around that current carrying conducting wire, perpendicular to that, magnetic field will be generated. Understood? The magnetic field lines will be generated. So this phenomenon is called as magnetism. Understood? Electromagnetism. But in respect to this, opposite if we are taking, opposite means one wire we are taking, just understand this one wire we are taking, just check this one out, understand this, कि if, good morning sir, good evening sir, so understand this one. So now here we need to understand कि when this is exactly a wire, understood, now this wire is not having any battery or cell, nothing this wire is having. Now what we are doing is we are going to attach one galvanometer here. So galvanometer, what is the work of galvanometer? The work of galvanometer is to, just 1 minute, huh? One monkey auntie is cleaning restroom, making so much sound. So what we are going to do here is, this is a wire. This wire do not have anything conducting. Okay. Only one galvanometer is there. What is the work of galvanometer? The work of galvanometer is to find the amount of conducting current inside it. So what is there is, this is a conducting wire. Now what we are going to do is, we will take one magnet and the magnet, north pole and south pole, and we will allow the magnet to go near and go away, go near and go away. What will happen? The electron present in the wire will be doing what? They will start moving in the wire, and then the galvanometer pointer will start doing deflection. So this is exactly showing one very important point. That very important point is, this is called as, yes, ma'am, then what is ammeter? Ammeter is finding the amount of current. Galvanometer is finding the amount of induced current. That is the difference between ammeter and voltmeter. Sorry, ammeter and galvanometer. Galvanometer work is to find the amount of induced current. Induced current means the current which is not live. See, ammeter will be connected in the live battery or cell. You need to understand this one. So if this is exactly a circuit, and this is exactly the connection, this is called as what? Battery. The amount of the number of cells joined together will become battery. There you can join ammeter. Understood? But here no battery or cell is there, then you can join what? Then you can join galvanometer. So galvanometer, see this wire, that's what, na, generator and everything is there. So that's what, in that case what will happen is ki here the current is exactly induced. Induced is not because of any battery. There is no potential difference generated in the cell. Here potential difference is generated. Positive terminal and negative terminal. Between positive and negative terminal, potential difference is generated. But here potential difference is not generated. You need to remember this one. So here potential difference is they generated. Here potential difference is not generated. Only galvanometer is connected to the wire. And since the galvanometer is connected to the wire, what actually has been done here is, the magnet will move in a to and fro motion. The magnet will continuously move, and the motion of the magnet in this wire will be exactly conducting current, and that's the concept here is. I hope you might have understood this one. So this is the basic difference between both the factors. Okay, I hope you might have understood this one. I hope you might have understood this part. So I hope you might have understood this one. So this is exactly about the conduction of current. I hope you might have understood this one. So now we will go for the next one. Yes, is it done? Did you understood deflection? I hope you might have understood this part. We will go for the next part. Is it okay? Can I leave this topic and go to the next part? So I hope I have explained what is the meaning of induced current. Induced current is not because of potential difference. Induced current is because of the disturbance in the external field. This disturbance in the external field will be exactly to and fro motion of the magnet. It might be due to the to and fro motion of the magnet. So this can be the reason behind conduction of current. I hope everybody understood. Who and all have not joined the session, seriously I punch you all. Remember that. So now let's go to the next part. So we have understood this section. So is it clear? Yes, Vishwa, over. So I hope everybody understood this. Is it clear? Is it clear? Last time I'm asking, is it clear that what is the meaning of what you called this induction? So now look here, magnetism has been a source of curiosity for ages. Magnets are commonly found in science laboratory, toys and in the magnetic stickers that we stick to refrigerator or steel almirah everywhere. So the earth itself acts as a magnet. Yes, we know that our earth is also exactly existing. It acts as a magnet. Many factors are there. I need to discuss about these factors. So magnetism has many uses, from the simple magnetic sticker to magnetic resonance imaging, that is MRI. MRI room also, the machine is exactly having a strong magnetic field. The machine itself is having a strong magnetic field. So now look here, a substance which attracts small pieces of iron, nickel, cobalt and steel and points in north-south direction when freely suspended is known as a magnet. So what is the definition of magnet given? The magnet is getting attracted in by which elements? Which elements got attracted towards magnet? Iron, nickel, cobalt, steel. Iron, nickel, cobalt, steel. These are some things which is exactly getting, yes, iron, nickel, cobalt and steel, they will be exactly getting attracted. I hope you might have understood till here. Till here, is it okay? I hope till here, is it okay? So this is exactly something very important to be noted here. So magnetic substance, a substance which attracts small pieces of nickel, iron, cobalt and steel and point in north south direction. Now natural magnet, now we are going to talk about natural magnet. Ila version, good evening. So now natural magnets are irregular in shape. Natural magnets are regular in shape or irregular in shape. Natural magnets are irregular in shape. Moreover, they are weak magnets. Natural magnets are weak magnets. Understood? And iron bar can be made by a magnet by rubbing with a natural magnet. Such a magnet is known as man-made magnet or artificial magnet. Like magnetic poles north and south repel each other. Unlike magnetic poles can attract each other. So you need to understand that there are two type of magnet. One magnet is a natural magnet, another magnet is a man-made magnet. Can you tell me what is the difference between a natural magnet and a man-made magnet? See, from where I can get a natural magnet? I hope students are present here right now. Let's talk about it. Vishwa, Ilavershan, Kavya, everyone, tell me about natural magnet and from where you are going to get the natural magnet. The place from where? Yashwit, can you tell me from where we can get a natural magnet? Which magnet is supposed to be a natural magnet? Which magnet is supposed to be considered as a natural magnet? You need to tell me that. Natural magnets are weak magnets. Indeed, natural magnets are weak magnets. That's not a big thing. That is not my question. From earth crust, very good. So that means we need to understand one very important point here is the molten magmas are there now. The molten magmas which is coming out from the earth as volcanic eruptions, these molten magmas will dry up and they will exactly become solidified objects, and these solidified objects will be exactly having some type of magnetic effects. Understood? So definitely nickel or any other thing present in that will have the impact on making a magnet. So they will be called as natural magnet. Now these natural magnet do not have a particular shape. So we cannot direct the north and south pole, and we cannot be able to make magnetic lines of forces. So yes, the igneous, that is igneous rocks. But here what we are doing a small work here is we will take the natural magnet and we will make a strong intensity magnet, and that will be continuous rubbing in a specific direction will make a magnet. Understood? So irregular magnet can get converted into, see, this iron bars will be, yes. So definitely they will be very very helpful. Now we are going to talk about historical backgrounds. So magnetite is so called, it was found in magnesia in Asia Minor. The Greek discovered the attractive property of the natural magnet, while Chinese discovered the directive property of the natural magnet. This is the basic difference. One has, remember this one identified that these rocks are something very unusual, but the other one has exactly talked about the directive property. What is the meaning of directive property? The directive property talks about the direction. The directive property talks about the direction. The directive property is talking about what? What is the highest powered magnet till now? Need to check. Highest powered magnet, I didn't know about it. Okay, so Earth physicists concluded that Earth behaves as a large permanent magnet. Earth is behaving as a large permanent magnet. Understood? Okay. Ayo, I am in live class. Tomorrow I'll give next. Lodestone are naturally magnetized pieces. Yes. Teslas are there. Okay, you are talking about the magnetic field. I think he's asking about the power. Unit of magnet is Tesla. That's something. Yes. Which was the most powerful magnet who created in a pulsed magnet with 100 Tesla of magnet? See, mostly it will come to 45, 45, 50. I think he's asking that only. I think he's asking that only. Magnetic Tesla. Pulse magnet, if you are going to about the pulse magnet, yeah, only 45. Pulse magnet can reach to 1000, then not 100. Pulse magnet can reach to 1000. I think he's taking that direction or this direction. I'm having confusion about that. What actually he is asking? Is he asking about the unit or about his pulsating magnet, pulse magnet he is asking, or the unit of that? That need to be checked. Okay, so now we'll go for our next part. So historical background. So English physicists concluded that the earth behave as a large permanent magnet, 100%. Now artificial magnet, that's what we were talking about. Yes, don't go there. Pulse magnet and all, this is exactly different thing. See, that is a different thing. Like, how to explain it? See, when you will be when we will be talking about pulse magnet, means the different type of magnet contents will be there, and they will run continuously. Understood or not? And before explosion, they will be pulsed. That's something you need to understand this part, and you need to understand. I can destroy a magnet. Okay, I can destroy a magnet. Someone is messaging again and again. I can destroy a magnet, and you know what I have to do only. If any type of magnet I am having, I want to increase the intensity of the magnet, means I need to keep on adding some. So that will be pulsed. Understood? But if I want to destroy it, I have to just change the direction, because magnetic field lines are exactly having specific direction. Direction distorted means magnet destroyed. Okay. The strongest magnetic field in the universe are found to be a type of natural star with magnetite. Okay. Heating is going to disturb the magnetic field. See, heating is going to disturb the magnetic. That is a very simple thing. If I want to disturb a magnetic field means I can change the direction. Direction change will also disturb the magnetic field lines. That's something very, very important. Now look here, in the beginning it was that electricity and magnetism have no relations with each other. However, in 1819, see, for you people what and all needed is this factors. Please kindly note down. 1819. So first it was discovered that there is no, yeah, first it was discovered that there is no interconnection. But after that we came to know that in 1819 Hans Christian Ørsted has exactly talked about the relationship between electricity and magnetism. First, we were exactly very lax, like there is no connection between magnetic and electric lines of forces. But after that, we came to know that there is a connection between the magnetic field and the current is exactly generating the magnetic field. That we have come to know. So he found that a wire carrying current causes deflection in the needle of magnet compass placed near the wire. Since needle of magnetic compass is tiny magnet, so it will be deflected from this its equilibrium position in another magnet is brought near close to it. So as the magnetic compass is placed near the current carrying wire, so the current carrying wire behaves as a magnet. So 100% we will be talking about this only because they will be asking you the direction. So from there, yes, from there, what is from this section, what type questions has been asked? So now, see, still I think some people are in pulse, disturb a magnet, destroy a magnet. That will be pulsed. Understood? That will be pulsed. See, equilibrium position will be that position where it will not going to show any deflection. Understood or not? So you need to understand that region also. So whenever any magnetic field lines will be there, then it will go parallel. It will not be showing. That I am going to teach. Don't worry. So also disturbs, ma'am. Yes, magnet vibrations also can be disturbing a magnet. So all the factors I'm going to teach in the PDF, everything is there. Okay. So but one by one, not in one shot. In the beginning itself, just giving a small introduction just now, starting only. So it will be deflected from its equilibrium position in if another magnet is brought close to it. As the magnet compass is placed near the current carrying wire, so the current carrying wire behave as a magnet. Now come on, I'm going to show you one thing. See, rest position. If any object is kept at rest position, now look here beta, understand this very nicely. So this is a bar magnet. Okay, now bar magnet will be showing north and south direction, correct? Understand, but this bar magnet is resting. This bar magnet is resting, no chain, no chain, no sign, nothing it is showing. But what is actually is done is it will have magnetic lines of forces. Don't think it is silent. It will have magnetic lines of forces coming from north direction to south direction, magnetic lines of forces. Okay, so these magnetic lines of forces or magnetic what you call this magnetic lines of forces will start from north direction, it will go towards south. I hope you might have understood this one. Till here, is it okay? I hope you might have understood this one. So magnetic lines of forces north to south. Yes, in outside it is north to south, beta. Outside it is north to south. Inside it is south to north. Yes, magnetic lines of force will never intersect. That reason also we will study in this PDF. Everything is there. Okay, one by one, one by one. Okay, I'll discuss that point also. But look here. First, though, we will come to know that magnetic effect of electric current. We are going to study about it. So, magnetic effect of electric current was given by whom? They will ask this question means you must be ready to answer. Magnetic effect of electric current was given by whom? What is the answer? The answer is Ørsted. So you remember the person name Ørsted, Hans Christian Ørsted. He was the one who has exactly able to find a relation between the current carrying conducting wire having magnetic field around it. The person who has said, see, Intersection is a different thing. I'm going to explain full entire factor with mathematics. Okay. So Hans Christian Ørsted, remember this one right now, one by one. Hans Christian that is Ørsted, is the person who had talked about the magnetic field generated because of the current carrying conducting wires. Understood or not? So now we are going to go to the second phase, important properties of magnet. These are some just small things. I'm going to explain about the properties of magnet, and then we will start to our major work. So property of attraction. So definitely we know that a small piece of magnet will attract another magnet. A small piece of, yes, a small piece of magnet can attract, just now we talked about iron, nickel and cobalt and steel. Okay, now what they are doing is they will be exactly kuti magnets are there. If we will join them together, it will become a big magnet, and the magnetic lines of force will be exactly bigger. The magnetic lines will become bigger. Understood? The magnetic field lines or magnetic lines of forces, magnetic lines of forces or magnetic field lines. Understood? So magnetic field lines or magnetic lines of forces. So dipole will be there now, right? Monopole means what? One single pole. How can it be? If you break now, if you will keep on cutting a magnet, that many gutti magnets will be there, and every single magnet will have north and south direction. Understood? So that's what it is called as dipole, means two poles will be there. One will be north pole, Yashvit, and second pole will be called as south pole. So north pole and south pole will be existing in every magnet. Understood? So now we will go for a freely suspended magnet always align itself with north south direction. This is one thing. Now next point is the pole which point towards geographic north is called north pole, and the pole which to geographic south will become south pole. But beta, this is not the correct thing. I will be discussing where is earth natural magnet inclination, that also I will be discussing. Okay, so but we know that like poles will repel each other and unlike poles will be attract each other. Okay, and unlike poles attract each other, just as like charge repel, unlike charge attract, same way like poles will be repelling each other and unlike poles will be attracting each other. Okay, a circular magnet also you will be having, in circular magnet in the face itself you will be having north pole and south pole. You will try to join them from the edge side, na, they will turn and they will join like this. Understood? So north, south, north, north south, north south, north south, like that. So face will be exactly having north and south pole in a circular magnet. Remember this one. Understood? So now we will be talking about, since a magnet can attract small pieces of iron and also the opposite pole of another magnet, property of attraction is not a sure test to find whether a given piece of a magnet or not. Repulsion is a sure test to confirm whether a given piece of magnet or not. Yes, but a repulsion can explain things much faster than any other thing. So magnet can show attraction and magnet can show repulsion also. Understood or not? So attraction is because see, I took an iron, what you call iron piece, and I kept it near the magnet. The magnet will attract the iron. So we can say that okay, one natural magnet I took, and in that near that natural magnet I kept an iron piece. The iron piece got attracted towards the magnet. So here it is not a very big deal that which one is a magnet here. Then that natural stone piece I have taken which act as a magnet, or the iron one, that then it will not be. But when two magnets will be there, they will definitely repel each other. That time itself we will come to know that there are two different magnets. Understood? When any other attractive things means the things which can get attracted towards magnet or magnet will be there will always be attraction only, repulsion will not be there. Oh, understood? So breaking of magnets successively into smaller piece would still produce tiny magnet, but their intensity will become small. Intensity means the magnetic field lines will become kuti, effect of that magnet will become less. Understood? So now the above phenomenon is observed till we reach molecular stage. That's the most important thing. Till it will not get converted into molecular stage, the magnet will show magnetic property. Okay, so magnetic pole always exists in opposite pair. Single magnet poles never exist. That's what Yashvit was talking about, monopole. So now we are going to talk about the next part. So magnetic effect of electric current, we are going to totally talk about this. So magnetic effect of electric current, one by one we are going to understand. When a bar magnet is suspended freely from its center by a thread, one end of the magnetic point towards the north and the other will be pointing towards the south. So end of the magnet pointing towards the north of the earth is called as north seeking pole, and the one which will point towards the south will be called as south seeking pole. So everybody knows this. This is not a very big thing. You must have seen a magnetic compass needle also. In that also you will be seeing that one needle will be placed, and that needle will be exactly pointing. The pointer will always to point towards geographical north. Understood? The pointer will always point towards geographical north, and it will be exactly considered as what? North pole. Okay. So the other end of the compass needle pointed towards south is known as south pole. Understood? So north pole and south pole. I hope everybody understood this one about north pole and south pole. Now we will be going for the next one. Get ready for it. When a north pole of a bar magnet is brought near the north pole of a magnet, repulsion will be there. Bhai, that is not a very big rocket science. Understood? Now I have one question to ask from all of you. Why north and north repel? Why south and south repel? What is the reason behind repulsion between north and north pole and south pole? Huh, that is exactly, but I want to know this answer. That the stone, the natural stone name. Come on, say. Okay, I got one answer, due to direction of magnetic lines. Others, do you have some other answers? Same charges repel. Do you think the example what you have given is very ideal in this situation? Is it very ideal in this situation? Very clever, Vishwa. But am having not this question. I'm having another question. I asked you one question, that why north and north repel one, why south and south repel? Their field lines push away from each other, creating a higher energy state which causes repulsion. See, both the cases will be energy state will vary, and because of that, attraction or repulsion will be there. But you need to understand one thing, how the magnetic field lines are exactly working. One time we are going to understand this. Now look here. For this one thing I will be teaching you, because these things I hope you might be understanding. See, to locate the magnetic field of a bar magnet, we use iron filling on a magnetic compass. When a magnetic when a magnetic compass is far away from a magnet, it is not deflected. However, when a magnetic compass is close to the magnet, it will deflect. So the space or region around a magnet within which a magnetic compass is deflected is known as magnetic field or bar magnet. Understood? So the magnetic field of which one, beta? Magnetic field of bar magnet. That's concept only I just read out. Now we are going to understand this by drawing. Okay, so now everything we are going to draw and explain, and I'm just going to explain you one very important thing, the repulsion. So why repulsion will be there? Understood? So I'm going to explain. I thought you people will come. Now look here. Now understand this part. I'm going to explain this one with much clarity. Why repulsion will be there. Yashvit answer is very good. I'm accepting that point. But the rest of this answer, to here and there, to and fro motion was there. It is quite difficult to understand this. Please remember this one. This is exactly a magnet. This is north pole and this is considered as south pole. Okay. So now when this is north pole, when this is south pole. Now understand this, the magnetic lines of forces will be exactly moving from north to south. Okay. So now north to south, the magnetic lines of forces are there. So all the magnetic lines of forces are coming from north and it is going towards which direction? It is going towards south direction. Got it? Now after this, what will happen? Another magnet will come having same north and south pole. Got it? So now when same north and south pole will be there, it will also have magnetic field lines. So what is the problem with intersection of this magnetic field lines? Okay, what is the problem with this magnetic field lines? Why can't they intersect each other? Come on, say, what is the problem with it? Why can't they intersect with each other? What is the big problem here? Why can't they intersect with each other? The correct answer is the magnetic lines of forces will not be intersecting each other because they should be always tangential. The force, the energy, repulsive forces, yes, the force, the energy which is exactly moving will not make it or allow it to intersect because the tangential direction has to be there. Understood or not? See beta, whenever any curve you are making now, the curve will exactly from one point of the curve, one direction will come out, and that is considered as, hello Violet, that is considered as a tangential direction. So here also tangential direction, here also tangential direction, here also tangential direction. So now what will happen? Given this magnetic field lines will have this one and this one is exactly coming this. So two direction is exactly generated. So once two direction are generated, it is not going to be in what you called in one specific direction, and that will violate the rule. And because of that, the repulsive force will not allow north and north to stay together. So definitely what will happen? The south will go and bind with the north. And then what will happen? Once the time when this south and north will be there, you know what will happen? The magnetic lines of force which is coming from north now, which is had repulsive force, now it will start going in south south. Are you understanding? The moment south will come in front of north, the lines of forces will not go like this. The lines will exactly start going inside the magnet, and then this magnetic lines of force will be generated. I hope you might have understood. And the moment like this will be there, the magnetic field lines will become more interactive, and this will go inside and it will stick to this magnet. And once it will stick to this magnet means now it is not two different magnet. Now it will become one magnet. Now it will become one magnet. So that means given the lines of forces which is having a specific energy moving in one specific direction will intersect each other, they will create two tangent lines, and these tangent lines will move in two different direction, and that direction will violate the rule, and definitely it will be energy. So it is going here and there, which will not be combined. So definitely that magnet will repel each other. So now what happened? One magnet is like this, another magnet went like this, it will be repulsion. But one magnet like this, another magnet went like this, means like a cell connected to a battery. Yes, the moment it will be like this, whatever magnetic lines of force coming from the second one, it will enter inside the first one, and then it will make big magnetic field lines. I hope you might have understood. Was this information effective? Did you understood this one? I hope you might have understood. So magnetic field lines, north and north will always be repelling. If we do like this, attraction. If we do like this, means repulsion. Understood? Because the lines of forces will intersect and it will break the rule of direction. Understood? Hi, Amya S. Arun. So now magnetic lines of forces we are going to understand. Okay, one question I am going to ask from all of you, where the magnetic field lines will be having strong intensity and where the magnetic field lines will have weaker intensity, means where the magnetic field lines are stronger and where the magnetic field lines are weaker. Near the pole, very good. The magnetic near the pole, the correct answer is yes, it will be very strong near the poles. So now we are going to understand this also. But why this? Because the cozy poles are exactly at the poles, it is very very strong. That's a very good correct answer. So we know that whenever magnetic field lines will be generated, the path along which the north pole moves in the, this is too much to read, we need not to read this part. You just understand that this is a magnet, and the magnetic field lines, you see the parallel lines are there now, they are exactly originating from very near parallel lines. So inside parallel lines, parallel field lines will be there. So these parallel field lines, according to the intensity, will start making closed curves. These are always closed curves. Remember that these are always closed curves. Understood. So these are always closed curves. Yes. So the loop will be closed. The curves are exactly closed curves, beta. So you need to remember this one, closed circular loops. Yes. And they will be exactly. So what happens inside the magnet is a uniform, what you call uniform parallel lines will be there, magnetic field lines. So when this uniform parallel magnetic field lines will come out, it will come out from the junction from where it is coming out there, the stronger magnetic field will be generated. So here, since the terminal, it will be exactly keep on moving out. So this is exactly the region of magnetic, strong magnetic field lines. So this and this will be exactly strong magnetic field lines. So these are they, where it will be near the pole. So a strong magnetic field will be there, and after that it will be, these regions will be weaker, this region will be weaker in between the regions. So how much far you will go, that much weak magnetic field lines it will become. Understood? So that much weak field lines it will become. Near this area you will not find any magnetic regions. Understood? So these are the strength of the magnetic field is shown by how much close these lines are. This is the most important thing. How much close these lines are, that much strong magnetic field will be there, beta. So few important points you will remember. Definition of magnetic field lines. What is, see, magnetic lines of forces. What is the definition of magnetic lines of forces, beta? The magnetic field is represented by series of lines around a magnet. So these lines represent the path of an imaginary independent north pole. If it were allowed to move freely in the direction of magnetic field, it will be starting from north pole and go towards south pole, and it will be making closed loops. Understood? But here, beta, what is the definition of magnetic field lines? The magnetic, the path or straight or curved, the what you call straight along with unit your north pole moves in a magnetic field is called magnetic lines of force or magnetic field lines. The magnetic field lines of the force or magnetic field lines are helpful to show the direction and strength. Definitely we came to know about it all, everything I have discussed. The next point is the direction of magnetic field line at any particular place is the direction in which the north pole of the magnet compass needle points if placed in that point. The strength of the magnetic field line is shown already. We have discussed about the strength of the magnetic field lines. So we have discussed, I have discussed about the strength of magnetic field lines. So if the field lines are very close to each other in a particular region, the strength of the magnetic field in that region is very large, like this. So here in this region and this region, the strength of the magnetic field lines are very, very large. Understood? So on the other hand, if the magnetic field lines are far from each other in a particular region, then the strength of the magnetic field line in that region is very small. The magnetic field lines around a bar are shown in the following. So let us check this one out. So now this is a practical learning. What we can do is we will take a cardboard, and in that cardboard, in one side of the cardboard, we will fix a magnet, and opposite side what we will do, we will put some iron fillings. So what this iron fillings will do, beta, these iron fillings will do one work. These iron fillings will align itself like this. Can you see the iron fillings alignment? How the magnetic field lines are so strong and how they are nicely making closed curves. So strong magnetic field lines will be generated. So taking a drawing board and paste a white sheet of paper on it, and then they are just telling the activity what you have to do. Okay. Very good, super. So now place a bar magnet at the center of the paper. Now sprinkle iron filling evenly on the magnet. Tap the surface of the drawing board, and you will be definitely getting this one. Okay. So we observe that iron filling are arranged in a pattern of showing in this. So this pattern consists of series of magnetic lines of force. So this is another important point to be noted. Now, plotting a magnet is also a very simple thing. You take a bar magnet and take a compass. The compass deflection will take from north pole towards the south pole. So that's something which is not so big rocket science. And here we are going to understand going on marking the north and south pole. This actually activity they are telling. Now, when one south and north pole will be there, rather than making the lines of forces like this, the lines will exactly come from north and it will merge towards the south. And when they both will combine together, a bigger magnet will be generated whose magnetic lines of force will be much bigger. That already I have talked about it. So now we are going to go for this one, this about we have discussed. So magnetic field lines, a pair of small poles of two magnets placed close to each other. You see north and north will be repelling each other. What is the reason of repulsion? So properties of magnetic lines we are going to study. Definitely we know that magnetic field lines are closed continuous curve. What loop you told na, closed loop. So this is exactly closed curves. It is exactly making coming out from north going in south. Inside they are parallel lines. Inside, see, outside they are making curve, inside they are parallel lines. Outside they are making curve, but inside they are parallel lines. Next point is the tangent to any point. Now this is the thing I want everybody to remember. Come on, Yashvit and everyone, this is the point I was about to discuss. Uniform magnetic field lines will be there. Understood? This will be having uniform magnetic field lines. Now look at it. These are the C. That's what I asked this question from what you call Yashvit, and I had a discussion with him about this, and we were discussing the tangent at any point on the magnetic field lines gives the direction of magnetic field. Remember this one. So the tangent at any point on the magnetic field lines, this tangent. So this is the magnetic field line and this is the tangent. The tangent at any point on the magnetic field lines gives the direction of magnetic field. It is giving what? It is giving the direction of magnetic field. So no two magnetic field line can intersect each other. So now why these two magnetic field lines cannot intersect each other? If two magnetic field line intersect at point P as shown in the figure, there will be two tangent at the same point, and definitely the two tangent will not be able to give one specific direction. So here it means that 2 point over there will be two direction of the same magnetic field, which is not possible. So two magnetic field lines can never intersect each other because two tangent will be generated. Every curve, one single point will give a specific tangent direction, and here how many tangent directions will be generated? Two tangent directions. Two tangent direction means one specific movement will not be generated, but magnetic field lines are having specific direction, which violate the this statement that magnetic field lines are having specific direction, because when they will intersect, the tangent will be exactly intersecting and putting this here and there, and this will violate the rule. So 100% this is not possible. So now magnetic field lines are crowded, yes, close to each other. Another important point is magnetic field lines are crowded close to each other in a region of small strong magnetic field, and where the region of weaker magnetic field will be there it will not be there. So these behave like a stretched bow and give a tendency to contract lengthwise, whereas attraction will be exactly in the opposite. So definitely this section is most important to remember. I hope you might have understood. So which shows attraction between two opposite pole. So can you see this? So this is the part we have already had discussion. Now this repulsion. So lines of force exert a lateral force of repulsion on each other. Can you see the lateral force of repulsion on each other? If you're seeing the lateral force of repulsion on each other, it will be similar poles will be repelling each other because the magnetic field lines will not intersect. That's another important point to be noted. Now we will type about types of magnetic field. Uniform magnetic field. First, so we will understand that how many types of magnetic field will be there. One magnetic field will be uniform magnetic field. So uniform magnetic field is said to be, a field is said to be uniform if equal means if its magnitude is equal and direction in the same at every point. So you see in this uniform magnetic field is there, so direction is same and width and the magnetic field lines are exactly uniform, parallel. So this is considered to be, so uniform magnetic field is represented by equidistant parallel straight line. This is considered as what? Uniform magnetic field. Now we will talk about non-uniform magnetic field. Can you see non-uniform magnetic field? The field lines will not be parallel. So such case it will be considered as non-uniform magnetic field. Okay, and its magnitude will not be equal and direction will also not be same. It will be represented by this. So this is the end of our today's class. In 20 minutes again I am going to start parabola remaining questions which are not parallel. Yes, correct only. Now, I hope Yashwit, did you saw that one beta, that intersection part, tangent lines of forces? I discussed about it, and because of that, the magnetic field lines will never intersect each other. Okay, the magnetic field lines will never intersect each other. Yes, so in 10, 15, 20 minutes, we are going to do probability, sorry, probability I'm saying, polynomial. After polynomial, linear equation case studies we will do. After linear equation case studies, we will do trigonometry case studies. So just give me a 10, 15 minutes break and then I'm going to start that chapter. Okay.